Okay, in these two questions, we are asked to sketch the region of integration in the above examples. This will make a little more sense and will seem a little more motivated. Well, hopefully it will seem a lot more motivated after lecture 28, but it's something that we can still do in this lecture to just make a point. So notice that in the integral on the left, the x values go from 0 to 1, and the y values go from x squared to x. So that means x is going from 0 to 1, and for every y value, y is going to go from x squared to x. So I'm just going to draw the xy plane, or draw part of the xy plane. That's the y-axis. This is the x-axis, and we're going from, say, x is equal to 0 to x is equal to 1. And for every value of x, so if I pick a value of x here, we're going to go from y is equal to x squared to y is equal to x. That is what the y values are going to go from. So let me graph y is equal to x squared. That's y equals x squared. And this is y is equal to x. Okay, so that's actually a little worse than I want it to be. So let me just fix this. Okay, I'm going to pause this while I draw the right picture. Okay, so now what we're saying is for every fixed value of x, we're going to go from y is equal to x squared to y is equal to x. And x is going to go from 0 to 1. So this is the region that we're integrating over for the integral on the right. Or sorry, the integral on the left. Now, for the integral on the right, y goes from 0 to 1, and for every fixed value of y, x goes from y to the square root of y. Okay, so let's draw this similarly to what we did before. Okay, so if I draw an xy axis, this is the x-axis, this is the y-axis. Y is going to go from 0 to 1. Okay, and for every fixed value of y, for every fixed value of y, x goes, sorry, I'm having trouble using the mouse. Okay, for every fixed value of y, x goes from y to the square root of y. So if we graph x is equal to y, the graph of x is equal to y is just the line y is equal to x. And in the first quadrant, the graph of x is equal to the square root of y is the same as the graph of y is equal to x squared. So again, something like this. So let me actually try to do this a little bit better. I'm going to pause it again while I can. Okay, this is the region. And what we're saying is that for every fixed value of y, we're going to integrate from x is equal to y to x is equal to the square root of y. Okay, but notice that these two regions are the same. Of course, my drawings are horrible, so it's difficult to see that, but these two regions are the same, okay? Because this is the graph y is equal to x squared. In other words, it's the same as the graph x is equal to the square root of y. This line is the graph y is equal to x, which is the same as x is equal to y. And that's exactly what these are. This graph, this line is y is equal to x. This curve graph is y is equal to x squared. Okay, so these two regions are the same. So we're integrating the same function over the same region. So the two integrals are the same. This is another statement of Fubini's theorem. We'll see a little bit more about that in a couple of lectures. In the next lecture, we're going to see what it means. We're going to get a better idea of what it means, what exactly these double integrals mean.